for you. This is actually 11 point. Yes, now we are discussing about 11.2. That is the topic of fundamental particles, fundamental particle physics. And in fundamental particle physics, actually, what we are going to discuss, that all is available here in this. This is the learning objectives. Just don't get worried about that. We will talk about the fundamental particles, that what are those fundamental particles and how are they classified. And secondly, we will discuss about that what are their properties. Third, we will discuss about that whether these fundamental particles are stable, unstable. Fourth, we will discuss about the quark composition of proton, neutrons. And then we will discuss about the positive beta decays and negative beta decays, and so on. Okay? Got
Yes.
it? Okay. So when we talk about the composition of matter, matter, yani, this is very interesting diagram. The main thing is molecules. Then molecules are molecules are decreased in size, then they become atoms, then nucleus, then protons and neutrons, and then quarks. So quark is actually the least smallest stable matter what we can find till now. Okay, so the size are given to you. So at least 10 power minus 8 meter smaller in size. This is an estimation for the quarks. So when we talk about the particles, we classify the particles into two main classes. One is the classical physics type, and the second one is basically the modern or quantum physics. In classical physics, anything which has rest mass mean, for example, me, I'm a particle, electron is a particle, proton is a particle. But in quantum mechanics, anything which has momentum, it does not mean that if yani, here velocity is equals to zero, but if here velocity will be equal to zero, then momentum will be equal to zero. So that would not be particle, so we will not accept it. You got it? So here are two main classes of your particles, and those two main classes of your particles are actually the leptons and hadrons, right? These are two main classes of the particles. The question comes from here. L for light particles. So when you will talk about the leptons are considered to be the light particles. Hmm. When the hadrons, H means the heavy particles. Actually, these are the Latin or Greek words, leptons and hadrons. So they mean the same, the light particles and the heavy particles. So there are some leptons. I have described it. The leptons are basically the light particles and etc. etc. The leptons are not affected by strong forces. Yani, as I told you, that because beta particles, neutrinos, antineutrinos, they all were having they were originated from weak nuclear forces. That's why they have no effect of strong nuclear forces. So all leptons have very small mass, and their examples are, this is the question which is asked to you in exam, that what are the, or underline the leptons from the given list, or what are the leptons, or which particles are from the lepton family. So lepton family is basically positron. As I told you, positron was basically the positive electron, plus 1 and 0. Electron, yani negative electron, minus 1 and 0. Antineutrino, that is 0 0 and minus above it. And neutrino, 0 0 and without any negative sign. So you have to recall these four particles. As I told you, that this is positive beta particle, this is negative beta particle. So you are actually having these four you know simple mechanisms which are considered as the fundamental particles. Okay, so you have to take care of these. Okay, is it clear to you? Then we have to talk about heavy particles. Heavy particles are actually the hadrons. They are affected only by strong nuclear forces, and those strong nuclear forces are those which are which are responsible to form the protons and neutrons. So actually, the examples of quarks are protons and neutrons. So neutrons and protons are the examples of the quarks. I mean, they are they are the examples of the hadrons actually. Sorry, not quarks. They are the hadrons. So type of hadrons are two. One are baryons, right? Baryons are those particles which are made from three quarks, right? Remember one thing. They are baryons which are made from three quarks. This is the condition that baryon consists of three quarks. Simply. Okay. And baryons examples are protons and neutrons in your syllabus. These two particles are actually the baryon particles which are existing more stable in the universe. Then second type of hadrons is mesons. Mesons are the particles which consist of one quark and one antiquark. Remember one thing, this is very important, that if there is a quark and an antiquark, I will let you know what are quarks and what are antiquarks. That's why I have used, yeah, here is that. So that is not a big deal. So quark and antiquark is basically the composition of a meson. Meson. Will you remember that word? Yeah, are you there?
Yes.
Okay. So quark model means we have to discuss about what are the quarks, what are their types, and what are the particles which are just made from the quarks. So I told you that fundamental particles which are combined from hadrons are quarks, right? So there are six types of quarks, their charges and their symbols. This is very important, very important. I will let you know how to recall it because it is not given to you. You have to recall it. Then questions are asked frequently from here. There are pair of quarks in Yani. They have set the pair of quarks like up quark and down quark. That is one pair. Charm quark and strange quark. That is another pair, and top quark and bottom quark, that is another pair. So in all these there are some common properties. Their symbols are UDC, STB, UCD and STB, but I have selected another format where your all UCTs, up, charm and top, their charge is plus 2 by 3e. What is their charge? Plus 2 by 3e. Okay. I have written this in Urdu, which is recall. What does it mean? You have to recall it. Right? UCT, UCT is up quark, charm quark, top quark, and they are having a charge, fractional charge. So actually, I can say that quarks are the particles which have the fractional charge. They have the fractional charge. And all DSB mean down quark, strange quark, bottom quark. They have the charge of minus 1 by 3e. What do they have? Minus 1 by 2 pounds of variance. They have the charge of minus 1 by 3e. So you have to remember that. Now, the top quark is basically the heaviest quark in the universe, and its mass is 200 times than that of the proton. Do you remember? Proton is considered to be the heaviest, but top quark is the heaviest quark, then 200 times heavier than the proton. So here can I say that the composition of a proton is basically, yani this is the question which is asked to you more frequently, that uh, what is the quark composition of a proton? So you have to recall it again. This is also a memory recall question, that a proton consists of up two up quarks and one down quarks. So because it consists of three quarks, so that is a hadron. What is that? It is a hadron, right? So proton is UUD, up, up, down. Now I will talk about the charge on a proton. That is that when we are going to find charge on a proton, that is a charge on an up quark is 2 by 3e, charge on the other up quark is 2 by 3e, and charge on a down quark is minus 1 by 3e. So when I will add all of them, we get 3 by 3e. So that is basically plus 1. That is why this is basically that reason that proton has plus 1 e charge. Got it? UUD is basically the reason behind that. That's all. Okay, now I will talk about the quark composition of a neutron, because you know neutron has a zero charge, so it must consist of those type of quarks which which combinedly give zero charge, and the quark composition of proton is UDD. UDD. Okay, UDD mean one up quark, two down quarks. One up quarks, two down quarks. इसको जाके लाइट ऑन करो बाहर वाले, पानी नहीं मार रहा है इसमें. Okay, is it clear? So one up quark has plus 2 by e. I told you UDC and DSB. UCT and DSB. So up quark has plus 2 by 3e, and down quarks have minus 1 by 3e, minus 1 by 3. So as a whole, did you see that proton has neutron has no charge? So it is basically neutral. We say that that is why it is neutral. So this is what you are asked in this topic. Then the charge change in the quark model of beta decay, right? Charge change in the quark model of beta decay. Actually, in beta decay, as I told you, that beta decay has two types. Beta decays are of two types, and those beta decays are actually in negative, sorry, in positive beta decay. This is positive beta decay. What happens? A proton is converted into a neutron, as I told you earlier, that a proton converts into neutron, and when a proton is converted into a neutron, along with that positive beta, a neutrino, and energy is released. So when you complete the quark composition, you now proton consists of three quarks: up, up, down. Neutron consists of up, down, down, and it has no quark at all, so that it does not have a quark, and then we have an energy. So overall, up quark is same, again down quark is same, so one up quark is converted into a down quark. So that is what you have to write in your exam, that during a positive beta decay, one up quark is converted into a down quark. So this is basically one of the reason of the positive beta decay. Then the negative beta decay or electron decay, in that one, what happens? A proton is converted, sorry, a neutron is converted into a proton. So neutron's quark composition is what? Up, down, down, and proton's quark composition is up, up, down. So actually what happens, that your one down quark is converted into one up quark with antineutrino and an energy. So I believe that you will be having when you will practice that, it would be very clear to you. Here the neutron changes to proton, so down quark changes to an up quark actually. Yani proton decays, the down quark decay into an up quark, and neutron decays up quark decayed into a new down quark, right? So you people can ask me, yeah, once you have asked, you have been asked about the quark composition of helium. What is the quark composition of helium? Because helium consists of two protons and two neutrons. So two protons mean 2 into one proton is up, up, down. Two neutrons mean 2 into up, down, down. So just multiply and add them together. So it consists of 6 protons, sorry, 6 up quarks and 6 down quarks. So overall, when you will put the charge number there, for up quarks and down quarks, you will see that the charge on the helium is equals to 4e. That is the reason that what is the charge on, sorry, 2e. What is the charge on helium? That helium charge is plus 2e, which is equals to 2 times 3.6 into, sorry, 3.2 into 10 is power minus 19 coulomb. So this is actually the all game of quarks. So here is a list of fundamental particles, right? Yes, one more thing. I have seen a question in which, let's say, we have a meson, and that meson is a lambda, let's say. If it is meson, if it is said that it is meson, then it must have a quark and any down quark. Let's say it is u and u minus. So UCT was plus 2 by 3e. Yes, what is important here? All anti-quarks, this table was consisting of quarks, and the table what I have shown you below this is your anti-quark. That is your anti-quarks. Also, anti-quarks are basically, oh no, here there is no anti-quarks. I have not mentioned. Just a second. Yeah, here I have mentioned those all. That anti-quark consists of all quarks have anti-quarks as well. Antiparticles of the quarks have same mass. This is asked in exam. That's why I have written. Antiparticles have same mass and exactly opposite charge. So if UCT has plus 2 by 3, then all U bar, C bar, T bar, they are antiquarks. They would have the charge of minus 2 by 3. And if DSB, it has minus 1 by 3, then all D bar, S bar, B bar, yani D, anti-D quark, anti-strange quark, anti down quark, sorry, anti bottom quark, they would all have plus 1 by 3. So that is the reason for all anti quarks. Anti quarks are those which have these bars on them. They have opposite charges. So UCT with bars have minus 1 by 3, where UCT without bar, it has plus 2 by 3 charge on them, fractional charge, and so on. So I would love to just explain the meson here to you. Meson. So if it is plus 2 by 3e and u bar is minus 2 by 3e, so what would be the charge of this meson? 0. Got it? Is it clear to you?
Yes.
Okay. So this is a list of fundamental particles. I believe that you will have no problem at all. So this was actually what I told you, that meson, pi meson and k meson. Pion, they are called pion and they are called kayon. Kayon. Mir, I believe that. I think so. There would be some name written for them. Pion and kayon. Right? So here is that point for beta decays. You have to remember that. And here is the classification are basically side information that hadrons consist of mesons, baryons, and antibaryons as well. So I told you two. So here are three. Mesons, they consist of one quark and one antiquark. Baryons consist of three quarks, right? And antibaryon consists of three antiquarks. Three antiquarks, right? Yani, if something consists three quarks, it is baryon. But if something contains three anti-quarks, it is anti-baryon. That's simple. Okay. Then these are the mesons I told you, right? They consist of one quark and one anti-quark. So this was all about the topic what we have learned. This was the chapter. So I have put some questions for you as well, right? These are the past paper questions. I believe that some past paper questions are also added with chapter number 1 and here with chapter number 2 also. So I strongly believe that that would help you out a lot. So if it would, inshallah. Okay. Any confusion or any query? You want to ask me something?
No.
I believe that I was in, I was just at a speed of F16. But the problem is, I gave you my words that in 2 lessons, inshallah, we will be done with this chapter, and you are supposed to practice for your midterm. And remaining syllabus we will start by the end of your midterm, right?
Yes.
So I believe that for this weekend